Oh, that was a little better. All right, students, today we're going to learn how to do, well, not how to do, but we're learning about atomic structure. So get your notes out, get yourself ready. We're doing atomic structure. You can find this in the important resources on Canvas. You can have a printout like me, or you can use an electronic copy. Either one works. If you need to pause the video at any time, go ahead and do that. If you need to get something ready like notes, or if you just need to pause the video and rewind to understand something that might have been difficult, do that too. Okay, so here are the notes. The modern view of the atomic structure. So the modern view of the atomic structure is basically, we've learned that the atom, which is the building block of all matter, has a structure, what it's built of. Structure means what it's built of. So this is our one of our most current views of how the atom is built. So atoms are made of 3 subatomic particles. Sub means beneath the atom, like kind of think about a submarine, like down low, or subway station, like down beneath the earth. Beneath the atom, there are 3 subatomic particles that make up the atom. Okay, and the first one is protons. The symbol for protons, you'll notice that I will write it like this, is P with a little plus. P with a little plus symbol. So there's an arrow that points to the atom's element. And the number of protons, I should say, determines the atom's element. So the element gets its identity from the number of protons it has. Okay, so atoms have protons. Atoms get their identity by the number of protons they have. So each element on the periodic table has a different number of protons. It's what gives those elements their identity. Protons are positively charged. That's what the plus means. And we consider them to have a mass number of 1. Okay, positively charged. They have electrical charge as well. The next subatomic particle is a neutron. This is the symbol for a neutron. This little circle doesn't mean 0. It means that it has a no charge. That's what you could say that little 0, this little not symbol means. Okay, the number of neutrons can determine an atom's isotope. Okay, you'll learn what this word means a little later on, but the basic gist of the word isotope is that there are different types of isotopes, and each element can have multiple isotopes, and that depends on the number of neutrons that are present. Okay, so these are kind of related right here, like this arrow. These are related. Neutrons have no charge, and the mass number is 1. So the neutrons and the protons have a mass number of 1. The last subatomic particle is electrons. It's E with a little negative symbol. The little negative symbol means a negative charge. The number of electrons will determine the atom's charge. Okay, so the number of electrons can be gained or lost within an atom, and that gaining or losing of electrons can determine the net charge or the overall charge that an atom has. So that gaining or losing of electrons, you might guess, but if you compare the positive charge protons with the electrons' negative charges within an atom, you'll get the overall net charge. So you compare them to figure out what the charge of an atom is. Electrical charge. Okay. The nucleus is the name for the center location of the atom. The nucleus holds the protons and the neutrons. So see, I'm using those symbols right away. Okay. The electron cloud is the space around the nucleus. Okay, in the electron cloud, if you would guess, it holds the electrons. Okay, so the number of protons determines the element. We talked about that briefly, but let's get into it. The atomic number is the number of protons an element has. So let's take two examples. These examples are how they look on the periodic table of elements. If you see hydrogen there, number 1, and you see xenon, number 54, way over here, number 54. Okay, so that number in the top, this number right here is called the atomic number, and it shows the number of protons. So the hydrogen element has 1 proton. Whenever there's an element or an atom that has 1 proton, we know that it's going to be the element hydrogen. Whenever there's an atom with 54 protons, we know that it will be the element xenon. Okay, and we didn't actually go over what this was called, this in the middle. This in the middle is just called the symbol, the element symbol. And we could say that this is the number of protons. Okay, this is something called the AMU, the atomic mass unit. Which is the average mass of all isotopes of 1 element. Probably a different way to write that, but yeah. AMU, average atomic mass unit. It means the average mass of all the isotopes of 1 element. Okay, these are words that you don't know yet, and they're going to be defined for you right now. We use a lot of different words that you don't know yet, like isotope and things like that. So let's practice. Which element has 14 protons? Well, you're getting good at reading the periodic table. This is the skill of reading the periodic table. So if you notice, the periodic table goes in numerical order from left to right. In the first row, it goes 1, 2, way over here. And then it starts 3, 4, skips the space, 5, 6, 7, 8, 9, 10. And guess what? You have to find number 14. If you found it, go ahead and write it down, but it is Si, silicon. So you could write the symbol, or you could spell out the entire element. Okay? How many protons does bromine have? So now we actually have to find the name bromine. So go ahead and you can pause the video so you can find bromine yourself. You're getting good at bromine. I'm going to give you a little hint though. Most of what we're going to see today is going to be in the top 4 rows, just the top 4 rows. 4 rows right here. 1, 2, 3, 4, all the way across. So bromine is number 35. There it is, numerical order. You can find it. Br would be the symbol for bromine. Next is which element has 5 protons and 4 neutrons? Well, I didn't talk to you about neutrons yet, but I did talk to you about protons, and I told you that the number of protons determine that element. The number of protons is the identity for that element. So all we have to do is find the 5 protons. So which one's 5? Number 5 right here, B for boron. It's not Be for beryllium because beryllium has 4 protons. So the question just wrote 4 neutrons right there just to maybe trick you a little bit. So it just said 4 neutrons. Doesn't matter how many neutrons there are. If there could be a million neutrons, which that doesn't exist, but there could be a million neutrons. But as long as it says 5 protons, that element is going to be B for boron. Okay? An element always has the same number of protons, but the number of neutrons can change. Okay, and you'll soon learn that the number of electrons can also change, okay? So an element always has the same number of protons. That never changes, but the number of neutrons can change. When the number of neutrons changes, that's what it's called, an isotope, okay? So you can write all these definitions down, write this whole page down, but similar, it says isotope is similar atoms with differing amounts of neutrons. That right there is the full definition. Okay, and then this is added. It's like dyeing your hair green. You're still you, your identity is still the same, but you're a little different. So an isotope is just a similar atom of the same element with differing amounts of neutrons. So here would be an example: uranium-238 versus uranium-235. This is a difference of, you might guess, it's a difference of how many neutrons might you think? It's a difference of 3 neutrons. Okay, so uranium-238 is stable. Uranium-235 is unstable. It's used for nuclear fuel. We like that one. That's the good one. That's the one that's going to help us get off of the fossil fuels and help save the planet, perhaps. But I think the problem of nuclear waste will probably just be passed to, like, 5 or 6 or 7 generations into the future. But we'll all be dead by then. Don't worry about that. Why do we come to school? To get the jokes. Okay, so right up here at the top, the symbols of elements are different depending on the periodic table, but convention always shows elements written this way. Okay, so X is an example of a fake element. You won't find X on the periodic table. So it's a fake element, just showing that the middle part right here. I'm going to draw a box instead of a circle. That's annoying. I don't know why. Okay, ready? This middle part right here is the symbol. That's the box. Okay, and over here on the top left-hand side, you'll see a little number. That's the mass number. And then the number of protons goes on the bottom left. And then finally, a charge can be written on the top right. So the number of protons determines what the element symbol is, determines what the element is. Okay, the mass number can change depending on the number of neutrons. The charge can change depending on the number of electrons. Whoops. Sorry if you were missing that, but go ahead and take those notes. Again, I was saying the mass can change and the charge can change, but the protons and the symbol, they'll stay the same together. Okay, so here's an example of sulfur. Sulfur, S for sulfur, has 33 as a mass number, and it has 16 protons, each with a mass number of 1. So, and then the charge is 2 minus. That's a negative 2 charge. The mass number equals the number of protons plus the number of neutrons. So simple math would tell you that there are 16 protons here, and if the mass number is 33, that gives you, I think 17 is the right answer. I'm just not confident. I'm going to check myself with a calculator. So I checked, and yeah, 17 is the right answer. Good, good. All right, so let's practice. Okay, so here's the symbol, and we're trying to figure out how many protons, how many neutrons there are. Well, just follow this at the top, and you see that the number of protons is written on the bottom left. So the answer is 6. And the number of neutrons, now this is not 12. You might want to say 12 right away, but 12 is the mass number. Okay, remember that the mass number equals the number of protons plus the number of neutrons. This is the equation we're working with right now. It's a simple addition equation. So if there are 6 protons and the mass number is 12, how much is the number of neutrons? It's going to be 6. Okay, you can figure that out any way you need to. Okay, oh, big numbers, don't get scared. Symbol, Hg, that's the symbol for mercury. That's a symbol for mercury, Hg. So number of protons is written up here, 200, is that it? Nope, that's not it. It's this one down here, 80. The number of protons is 80. That's why we wrote this right up here. Number of protons, 80. Neutrons is going to be, oh dang, I can't do this math in my head. 200 minus 80. What is that going to equal? 120. 120 neutrons. Woohoo! Okay, you do this one on your own. Okay, you do this one on your own. Pause the video, figure it out if you need to. Do this one on your own. Pause the video, figure it out. Figure it out. Figure it out. Oh wait, I didn't teach you. This one looks different. So these are different ways that you can write elements and give a lot of information. So this is one way to write elements. This is another to write the symbol of an element. You can just spell it out, magnesium, and then 26 is the mass number. So this is the mass number. All right. Now you should be able to figure out the number of protons and the number of neutrons by looking at the periodic table. You're learning how to use this bad boy, periodic table. Okay, charges. Charges are the difference between the number of protons and the number of electrons. So an atom is always neutrally charged, meaning an atom has the same number of protons and electrons. Now that's really easy, but here's our little note. Atoms have no charge, so the protons equal the number of electrons. So same number of charges all the time. So for example, aluminum on the periodic table right here, aluminum 13, number 13, has 13 protons. So aluminum atom has 13 electrons. They're electrically neutral, and you can think of it like this. The example that I gave was aluminum is 13 protons, and that if you add that to the 13 electrons that it has, that equals 0. 13 positives plus 13 negatives equals 0. So that's atoms, but atoms can change, and when they change, we know they have different names, like you just learned about isotopes. So if atoms have a different number of neutrons, it's called isotopes of that atom. But if atoms have different number of electrons, we call them ions. Ions, and the word is right here. Ion, I-O-N-S. I-O-N-S. And if they're positively charged, they're called cations. They're called cations because they're positive. Oh man, she missed my joke. Anions are negatively charged. You can think about it like this, a negative ion. So these are two different names for when there's a difference between electrons and protons. So here's an example. Sodium is written with its mass number right here, its protons right here, and look, there's nothing written right here. That means it has 0 charge. That means this sodium is an atom. This Na for sodium is an atom. It's not a cation or an anion. It's not an ion. This is an atom because there's no charge written right here. So we know the number of protons is 11 as review, and that must mean the number of electrons is 11. All right, let's do another practice problem. Okay, so now we have a charge written right here. It says 1 minus. That's going to be interesting. Let's figure this out. Okay, F for fluoride. The number of protons is 9. We know that because of this 9 that's written right here. That's review. Now, how do we figure out the number of electrons? Well, we know that this is a -1 charge. Well, if we have 9 positive protons plus how many negative electrons would we need for there to be an overall charge of -1? Simple algebra says that we need to isolate electrons on one side of the equal sign. So we have to subtract away 9 positives. So what's -1 minus 9 positives? That's 10. So there are 10 electrons in fluoride anion. So this would be called fluoride anion. This is no longer an atom. We wouldn't call this an atom. We would call this an anion. Okay, let's do a positive example. All right, so this is 26 protons, a mass number of 56, and there's a charge of +3. So we know that the number of protons is 26 for this symbol Fe, and this symbol Fe stands for the element iron. Fe is iron. Okay, you go ahead and pause it, try and figure it out yourself. All right, we're unpausing the video, and this is what's happening. We're doing equals a +3 charge. I got that +3 from right here. And there are 26 positives plus how many negatives must there be for there to be a +3 charge? 23 is our answer. All right, and this last one. Let's see if you can do this one on your own. Let's see if we can do this one on your own. Sulfide is the anion for sulfur. So now you can use a periodic table to figure that out. Sulfide isn't written on the periodic table, but sulfur is written on the periodic table. You get the "ide" suffix when it becomes an anion or a cation. Which one is it? When it becomes an ion, you get the "ide" suffix. for the nonmetals. All right, these are 3 more examples. Go ahead and pause the video. Go ahead and pause the video and work them out, and then I will show you the answers in a moment. All right, here we go. We're going to show you the answers. Oh, I meant to actually write the answers in. Bam, there's the answers. Woohoo! What'd you do wrong? Figure it out. All right, so in this section, we're going to draw out all the different parts of atoms or ions or isotopes. And we have 2 examples that we're going to draw. Just in case you're super confused, we're going to draw out all the different parts, and you can really like count on all the different ones, all the different parts. Okay, so it says draw a picture of a neutral beryllium atom. So let's find beryllium on the periodic table. Everybody find it. It says draw a picture of a neutral beryllium atom with 2 neutrons. So where is beryllium? Okay, there it is right here. There's the beryllium. We're going to draw the protons and the neutrons in the middle location called the nucleus. So I'm drawing this as the middle location. There's 1 proton, there's 2 protons, there's 3 protons, there's 4 protons. And then it says to draw 2 neutrons. Let's draw the 2 neutrons right below it. So we got our protons and our neutrons all mixing around there in this nucleus location in the center. What goes around is in the electron cloud are 4 electrons, and we'll draw them like this. 1, 2, we'll draw them in a circle, and 3 and 4. Okay, so this is all about drawing the correct number of protons and neutrons in the center location. And it's all about drawing the correct number of electrons in the electron cloud location. So you can pause the video if you want the challenge, and you can draw a picture of a neutral carbon with 8 neutrons. Go ahead and pause the video, draw yours, and see if it looks similar to mine. I'm going to start drawing mine now. Okay, first I'm going to find carbon. I found carbon on the periodic table. There it is. It's number 6. Okay, carbon number 6. And the number 6 tells me that there's 6 protons. And since it says that there's a neutral, it is a neutral carbon, that means that it's going to also have 6 electrons, because 6 positives plus 6 negatives equals a neutral charge. That is a no charge right there. 6 positives plus 6 negatives. Okay, so let's draw our 6 protons in the middle. 1, 2, 3, 4. And we'll draw some right here, 5, 6. And then we also need to have 8 neutrons. So this is an example of a carbon isotope. So 8 neutrons, 1, 2, 3, 4, 5. Oops, I kind of drew that weird. 5, 6, 7, 8. Okay, this is the nucleus. This is the nucleus. And we need to draw our 6 electrons. 1, 2, 3, 4. Let's draw this. These are the first 2. That's 1, 2, 3, 4, 5, 6. And we'll connect all those electrons inside of the electron cloud, sometimes called an orbital. All right, that's how you draw them out. That's a more in-depth look of the atom and the atomic structure. All right, now we're going to fill out this table. You go ahead and keep watching the video, and pause the video if I'm going too fast, and I'm just going to put the answers down using my periodic table. You need to use the periodic table. You need to get good at identifying where the elements are on the periodic table. Where'd my periodic table go? There it is. Okay. Note the directions, please. Iron on the periodic table. Found it. There's the directions at the top. Sorry about that. Okay. Found it. There it is. Number 26, symbol, element symbol. Put it in. Fe. Boom, there it is, iron. Number of protons. Oh, I just got to find the number that's in the box. 26. Woohoo! So number of electrons when neutral, well, that's easy. Neutral means that the number of protons and the number of electrons are the same number. So there's got to be 26. Man, this is an easy chart to fill out. Let's go to the next one. Hey, AU, AU, AU. You know what I'm talking about? AU. What symbol is AU? Let's find it. AU right here is gold, number 79. Whoa, there it is. Number 79, it's gold. Woohoo, gold. It says number 79. That means we have to write gold first. That means there's 79 protons, and it's electrically neutral, so the number of electrons is 79. Uh-oh, let's take a look at this next example. It says there's 92 protons. What, it doesn't give me the symbol or the name. What am I gonna do? I'm gonna have to look at the periodic table. Uranium, okay, number 92, U for uranium. So we write the symbol here, U, and the name, uranium. Okay, next one. Oh, we forgot to put the 92 right here. Okay, next one is K. What is K? Let's find the K on the periodic table. There it is, number 19. Oh, hi, Walker. Number 19, there it is, K for potassium. Sweet garbage truck, Walker. And then there's, look at the number in the box. See, K, number 19. 19, it's number of electrons when neutral's got to be 19. What do you want to show me? Okay. You can show me the garbage truck. There it is. Okay, ready? Next one is number 13, sodium.
I want to stand.
Wait, okay, you want to stand. Okay.
I want to stand.
All right, how about this? You do the rest of those problems. I think you could figure them out. And that is today's lesson. Say